As with a 2D plot, when we do a 3D plot using something like Mesh or Surf, we may not like what MATLAB gives us by default. So here I have a script which will generate a saddle function, which I can run and show you that. So it's just a standard ax squared plus by squared equals f of xz. So I start by generating x and y, setting some coefficients, using MeshGrid to calculate my x and y matrices, then calculating my function z, and then plotting the mesh. So one thing I'll point out here is that I've used this figure bracket 1. This is useful for generating figures and keeping track of them, because all these parameters, x label, y label, z label, the set command, etc., operate on the active figure, which means that if you want to have multiple figures and manipulate them, they have to be active in the window. And you also don't want to overwrite figures. So if you want multiple plots, you'll either have to use hold all, or you just delete something. So if I now said plot, well, just a straight line, x, y. After this, if I run this now, if I was hoping to see both plots, all I'll get is this one plot that I've done last, because it will overwrite any other figures that are present. So what I have to do, or one way around this, is to manually generate my figures. And if I put a breakpoint on this line and run it, we'll see that what that does is it creates a blank figure, which is now active, which I can then put things on. So then if I had figure 2 here, I run this, I would then run to figure 2, so that will plot everything on figure 1, and then this next line will generate another blank figure, figure 2, which I can then put something else on. So now I will have both of these figures as separate windows, which I can manipulate and do things to separately. Okay, so we may not like how this looks. So one thing that's common with the 3D plot is we want to look at something like this to begin with. We want to look at the top-down view of this plot. So we can actually get that from our script when we write this, and we do that using a function called view. So what view does, since we're not really sure at the minute, we go to the command line and type help view, or doc view if we want more detailed information, it's the 3D graph viewpoint specification. And we give it an azimuth angle and an elevation to set the angle of view from which an observer sees the 3D plot. So AZ equals 0 and EL equals 90 is directly overhead and the default 2D view. So if we call this now with 0 and 90 as specified, and then run this, that will give me my default top-down view. And notice I've added these axes here, which in 3D plots are particularly useful because they let us actually know where we are. So we have X and Y. But if we wanted some other view, if we wanted a side view, for example, we could set the azimuth and elevation to 90 and 0 and run that, and that would show us the side view. Okay, so if we're going to go and take a top-down view like that, that may actually be all we're interested in which case we may be better off using something like a contour plot. What contour does is it operates in a very similar way to mesh, but it will just give us the ISO lines of specific heights, which we can see here. With a contour plot, there's a couple of other things we may be interested in doing, such as if we just run this now, I can't, for example, set how many values I have as contours here. I'm stuck with the default that it gives me. So I can change that in my call of the contour function by overriding its default value with something of my choosing. So say I only want 3 levels at which to specify these heights. I can set 3, and now I only have 3 different colors: brown's 1 level, green, and blue for my 3 levels. Alternatively, if I want to have contours at specified values, so say I want to know where the 0 crossing is, or where z equals 1, 2, 3, I can call this with my own vector of heights that I want my ISO bars to appear at. And that will give me a plot that looks like that, for example. And finally, the last thing we may be interested in, particularly with mesh, but as well for contour, is we can add a color bar to these plots, and what that will do is show me what height each of these colors represents. So red is a value z, or f of xy is equal to 300, whereas blue is a value of negative 200, which is also quite useful for visualization. And I can also, of course, add that to my contour to get a similar looking plot.